you, Yanni, for the talk. It's a real pleasure to have a blockchain influencer among us. Now, moving on our next talk, we're still wondering which areas of our daily lives blockchain will affect the most. The majority is currently focused on payments and various transactions. Stanislav Dimov, one of the Quanterall's talents, will present how blockchain can be paired with augmented reality for making coffee. Now I'm sure that the majority here loves coffee, so let's welcome Stanislav on stage.
Hello, everyone. Let me just prepare the presentation. OK. Sorry for that. Hello, my name is Stanislav Dimov, and I work as a software developer at Quanterall. And today I'm going to talk to you about a rather simple but a powerful concept. But before we start, I would like to thank all my colleagues for the time, dedication, and the awesome job they did to make this demo a reality. So nowadays, everyone strives to make his or her life easier. And we in Quanterall know that. We try to help you achieve it by implementing the latest and greatest technologies into the IT sector into the development of our products. In recent years, technologies like blockchain, Internet of Things, and augmented reality started gaining popularity faster than ever before. And these powerful technologies are still in their infant stages. But we in Quanterall believe in the huge potential they hold. But how can we use them to our advantage? Well, let's imagine a few scenarios. How many times have you been in a restaurant, ready with your order, but you had to wait for the waitress to come and take it? Imagine being able to walk into the same restaurant and make the order without having to wait for the waitress, by just looking at the restaurant table. Or perhaps, maybe you want to take a nice bike ride in the park for an hour on Sunday. Well, imagine being able to walk towards the bike stand and rent the bike without having to do anything but to look at it or point it with your phone. The possibilities are really endless, but for the purpose of this demo, we're going to start with something simpler. We're going to turn an average off-the-shelf coffee maker machine into a smart coffee maker machine. So let's take a look at the visual representation of the general idea. Using a blockchain to make financial transactions isn't something new. In fact, this is how a typical transaction, a typical purchase of coffee, is going to look down at your local coffee shop if it were using a blockchain. You, as a client, you ask the cashier for a cup of coffee, for which you're going to make a transaction on the blockchain designated for him, and when he receives the right amount of tokens from you, he's going to use the coffee maker to prepare a nice warm cup of coffee for you. That's pretty simple. But now, let's modify our workflow a bit, and let's make it more automated. Here's the same visual representation. But this time, you're going to use your phone's camera. You're going to point it towards the coffee maker. The phone is going to recognize then the coffee maker, and it's going to prompt you with a menu. And on the other side, the cashier is replaced by a coffee providing service. The coffee providing service will be listening for transactions designated for it on the blockchain. And when you're ready with your order, your phone is going to make a transaction on the blockchain designated for the coffee providing service. And when the coffee providing service receives the right amount of tokens from you, it's going to ask the coffee maker to prepare a coffee. OK, so knowing the general idea, let's just take a deeper look at how each of the components work together. But before we start, I would like to point out that this presentation is only a proof of concept, and therefore the implemented workflow is not final and is subject to change. And this is how the actual workflow looks like. But let us take a deeper look at each of the components one by one. First, our Android app. It uses the Unity development platform and Google's AR Core, and its job is to recognize the coffee maker and to prompt you with a menu. And when you choose your desired beverage, your phone is going to make a HTTP request with all the information about it, and is going to send it to your white note. Of course, since this is only a proof of concept, our white note implementation is extremely simple and is not intended to be used in a real case scenario. In a real case scenario, that white note is going to be replaced by some type of wallet or perhaps even a hardware wallet. In our implementation, our white node receives the JSON from the Android app, and then it forwards it to the full node by making a spend transaction request. Of course, the full node is a trusted node. The full node will then prepare a spend transaction, is going to serialize it via RLP, and is going to encode it in base 58 in order to be able to send it back as JSON. The white node will receive the RLP serialized data, is going to decode it from base 58, and is going to sign it with the sender's private key. Then it's going to encode both of them back in base 58, and is going to forward them again to the full node. This way, the white node and the Android app don't know and don't care about the structure of the spend transaction, and even if the structure is changed, they won't be affected. Our white node is running on one of our servers, and we consider it trusted. We're going to use it during this demo to mine our blocks with it. Each time a new block is mined, the full node is going to, broadcast the new mined block to a WebSocket on which the coffee provider will be listening. Of course, in order for the coffee provider to communicate with the coffee maker, we use an MQTT broker, which, as you can see from the illustration, hosts a topic called coffee machine. And in it, the publisher, which is our coffee provider, can post a message about the desired coffee type. On the other side, the coffee maker is going to receive that message and is going to act accordingly. The coffee provider, of course, is the middleman between the blockchain and the coffee makers. It knows every coffee maker's public address and listens for transactions designated for those addresses on the blockchain. Every time a new block is mined, the coffee provider is going to go through each and every one of the transactions and is going to look for transactions which receiver's addresses are one of the coffee maker's public addresses. If it finds such a transaction, it's going to look at its payload, which is the desired coffee type, of course, and the amount of tokens sent. And if the amount of tokens sent are enough for the desired type of coffee, it is then going to ask the designated coffee maker to prepare the coffee. And as we discussed previously, the coffee maker is subscribed to the MQTT broker's topic, and each time it receives a message, it acts accordingly. But I know that you're all guys excited to see the live demo, so let us, without further ado, go straight to it. Thank you. That's all. Okay. Okay, so this is the Android app we talked about, and I'm now going to try to prepare a coffee. Let's hope how this works. So it should recognize the coffee maker now. Oh, come on. Oh, there we go. And now I can choose a normal coffee or a double coffee, but I'm going to choose a normal coffee because I'm cheap. And let's prepare the coffee now. as we discussed, there is a slight delay here because the only thing that's not guaranteed here is the time delay between the actual purchase and the actual making of the coffee. And this is because a new block with the desired transaction in it has to be mined in order for the coffee provider to be able to confirm the purchase. Therefore, it is recommended to use a type of blockchain that generates new blocks as fast as possible. In our implementation, our blockchain generates a new block roughly every minute. Okay, I don't know why the screen is lagging, but well, oh, there it is. Started making coffee. Oh. Okay, so I'm not sure. Actually, I'm not sure. Do we have the page where we can see the balances between both of them? Could you come here and help me, please? And there we go. We should have showed you this earlier, but I'm going to prepare another coffee, and hopefully these balances should change. Waiting for the block to be mined. Okay, there you go. It changed. Thank you. We're running a bit late on the presentation, so do we have a time for a Q&A? Perhaps 2 minutes? One question, if anyone has one. Yes? Well, the goal is to make it work on every blockchain, but as we discussed, in order for it to be efficient enough, the blockchain has to be quick enough in generating new blocks. So technically, yes, it can be done, even on Bitcoin, but then you have to wait quite a while for a coffee. Well, right now it's on the main blockchain, but it could be, could not be. It could be on a separate one. Anyone else? Okay, thank you.